Hello, honors friends. We are actually practicing a flipping the classroom kind of procedure. You are doing your lecture notes at home, and when you come to class, we're going to do some activities to support it. So I'm going to talk kind of fast because I have a time limit on how big these videos can be, but if you need to pause it, please do, to make sure that you can get your notes taken as I'm talking. We're talking about section 2.2, the distributive property. It's another property. We talked about associative and commutative, and now we're talking about distributive. Distribute in English means to pass out or to hand out or to give everybody an equal amount. In math, distribute means the same thing. It has to do with distributing or giving, multiplying a factor to each term that's inside some parentheses. So we've got multiplication going on when we have distribution, and we're going to do some examples. You're looking for parentheses when you're doing the distributive property. And let me get down here where they've got the actual math property here. Distribution means you take the number or variable on the outside of the parentheses and actually distribute him to each piece that's on the inside of the parentheses. The signs are important, and I'll tell you as we go along how you look at that. In this case, the distributive property says take a positive A, and multiply him times positive B. You get AB. Take positive A and multiply him times positive C. You get positive AC. The second example down here just shows you that A can be written on the either side of the B plus C. That's our commutative property at work. And over here we've got some distribution going on with a negative number inside the parentheses. Take A, distribute it times B. You get AB. Take A and multiply him times negative C, and you get negative AC. And again, the commutative property says we can do it in either order. I've got some numeric examples that I'd like us to try together. We're going to distribute 9, multiply him. 9 times A is positive 9A, and 9 times positive 6 is a positive 54. Similarly, the second example, 4 times 2x is 8x, and 4 times positive 7 is positive 28. I've got a few more examples. If you'll just follow along as we go. These are numbered kind of crazy. I've got a couple number 5s, but that won't slow us down. On this first one, 3 times y, 3y. 3 times negative 12. I have that negative sign underlined because the negative sign goes with the 12. 3 times negative 12 is negative 36. And the parentheses are gone, which is what we want when we distribute. Number 4, negative 8 times 4x, negative 32x. Negative 8 times negative 6, positive 48. Number 6 is important because on your notes, you don't have a 1 in front of this x, but there actually is the ghostly 1, I call him, because you can't see him a lot of times. So if you want to go ahead and add a 1 after that negative sign, your problem becomes 6x times positive 1, which is 6x, and 6x times negative 1x. You can multiply your numbers together and get negative 6, and your x's multiply together to give you x squared, x to the second power. If you'll please look at number 8 on your own with the ghostly 1 and the distribution, and also this first number 5 up at the top with the distribution. I really want to skip down and talk about this number 5, the second number 5 right now. He's different than the ones we've worked before because he's all numbers. So there's actually 2 ways we can do this. And you can see in the blue, I've worked it one way by doing our normal distribution. Negative 3 times negative 7, positive 21. Negative 3 times positive 5, negative 15. Negative 3 times negative 2, positive 6. 21 minus 15, and then 6 plus 6. The other way to do it is to go ahead and simplify inside your grouping symbol and do a negative 7 plus 5 is negative 2, and negative 2 and negative 2 more make negative 4. And then do your distribution. Multiply negative 3 times negative 4 and get positive 12, the same answer. You only have that choice when you're dealing with all numbers. When you have numbers and variables, you have to do the distribution the way we've been doing it. I'm going to let you work number 7 on your own, and we'll check it when you come back into class. And then I wanted to talk to you a little bit. Obviously, pull this shade down a minute. Whoa, I don't know where he went. Let me see. Kind of got a mess going here. I wanted to talk about this reverse distribution, if I can. Okay, I'm back on track. Now I figured out where I am. This 2x plus 8, if I ask you to distribute, you'd say, Mrs. Leininger, I can't distribute. I don't see anything in parentheses. There's nothing on the outside to multiply. But what I'm actually asking you to do is go back the other way. I'm giving you the already multiplied, the already distributed end product, and I want you to go back and tell me, what did it look like when the parentheses were there and when there was a factor to distribute? So we ask ourselves, okay, what would be on the outside that I could take away from each one of these terms so that when I multiplied back, I'd end up with 2x plus 8. So we might ask ourselves, what could we divide a 2x plus 8 by? In other words, take the same thing out of both of those terms and then end up with something on the outside to multiply back to distribute. So I'm seeing a 2. A 2, I can divide a 2 out of 2x, and I can divide a 2 out of 8. So I'd end up with 2x divided by 2, or just x, and 8 divided by 2, which is 4. And the good thing about this reverse distribution is it's really easy to check. You take what's on the outside, multiply it back, and see, do you get what we started with? Do you get 2x plus 8? Yes, I do. 2 times x is 2x. 2 times 4 is 8. Okay, let's keep going here. On the second example, I'm asking myself, 6x plus 9, what can I divide out? I've got question marks down here. What can I take out of 6x plus 9? And I see a 3. A 3 will come out of 6, and a 3 will come out of 9. I can move the 3 to the outside, and what's left when I divide 6 by 3 is 2x. And when I divide 9 by 3, what's left is 3. And I check my work to see, did I start with what I ended up with? 3 times 2x is 6x, and 3 times positive 3 is 9. Okay, let's run on to the next page. It's an area problem. I have put my parentheses around the 2y plus 1 and the 3x minus 8. And I'd ask you to do that on your paper now. That's going to be an important way to remember that these probably are going to be distributed. I'm going to start with my formula. Always start with the formula. Area equals 1/2 base times height. 1/2, my base is 16. My height is 2y plus 1. I've got 3 terms to multiply together. It doesn't matter which 2 I start with because the associative property of multiplication tells us about that. So I'm going to say 1/2 times 16 is 8. And now I'm going to distribute. My last step is distribution. 8 times 2y is 16y, and 8 times positive 1 is 8. I'm going to let you guys finish the second figure. Please be sure your parentheses are around the 3x minus 8. Write your formula, as I have done for you. Write your shell. These are the places you are going to substitute in the dimensions we've been given. And then do your distribution. I've left some blanks here that we're not working on this video that you're going to work on your own. And when you come back to class, we'll figure it out. Here's another reverse distribution, one that I did fill in for you. Again, I'm asking myself, what can I take out? What do these two terms have in common? They have an x in common. When I divide the x out, I end up with 6 and y. When I multiply back, I've got what I started with, 6x plus xy. You guys give the others a try. See what you think. I've got 2 more area problems. I've done one for you. You can follow my work. I've decided to find the area of the entire rectangle and then subtract out the little piece that I don't need. Area length times width, x plus 3. This is 6 because of the 5 plus 1. Area of the guy I want to subtract out is 10. and I do the subtraction 6x plus 18 minus the 10, and I get 6x plus 8. You guys try this house looking one, and we'll talk about it in class. Thanks for watching. Bye-bye.